Let's do this circuit and apply Kickoffs law of current. So here we've got this loop and this loop. We also have this loop, which is the third loop. Again, we have that loop, which is the fourth loop. We have this loop also, which is the fifth loop. So we've got a lot of loops, but on entry they will tell you which loop to go for when setting equations. So you must use that loop. So in this case, we're gonna take this loop and this loop. So let us set an equation for loop 1. So for loop 1, what do we know is the total voltage. And what else do we have is that resistor. So a voltage across that resistor will be calculated by taking R5 resistor and multiply R5 with the current across the resistor, which is I1 minus 0,2. We again come across this resistor, which is R40. So R40 will then be calculated by being the voltage across R40 will be calculated by taking R40 and multiply R40 with the current, which is I2. So on this case here, we need to substitute. What is R5? As said, is 5 I1 minus 0,02. Please watch the part 1 of this series of Kirchhoff's calculations to understand why where am I coming from with this step. Now let us add R5, sorry, R40 is 40 ohms, right? So we put back I2 because it's the unknown. So here we will have 5I1, and what is 0,2 times 5 is 1. So we'll have minus 1 plus 40 I2. So remember we have 4 here. So we add 1, then 1 cancels 1. We then add what we do on the other side, we also do on this side again. So we add 1. So we'll have 5 equal to 5I1, and this is gonna be 40I2 plus 40I2 plus 40I2. So if you want to, you can divide 5, then here you will be left with, if we divide, I would also accept this equation, but someone might want to take this further, and 5 divided by 5 is 1, and 5 divided by 5 leaves us with I1, and 40 divided by 5 is 8, so 8I2. So this is our first equation. Now we need to come to this loop and get the second equation. Okay, on this loop, this is what we had. Let me see if I can get this paper. On this loop, when we're using this loop, this is the situation that was. Like if we isolate this loop, this is the situation that we have on loop 1. It's good to understand this because you might have a question on what we're gonna do on this loop. This is the situation that we had. So 40 So when we went for this loop, so this is the situation that we had on loop 1, and we had a current there which was called I1, and across this resistor we had a current which was I1 minus 0,2A. So don't take this as a series circuit, just take it as a loop, as taken as it is there, because now you will have a problem if you do that, because in a series circuit we won't have a different current over here and a different current here. So across this resistor we had I2. So why am I taking this loop out of that circuit? Is because I want to show you something. Current was going that direction, then when it after R5, current was going this direction, current going this direction, current going this direction. So we had current in the same direction. But do we have current in the same direction on loop 2? So check what's happening with loop 2. We have 5 ohms and 40 ohms resistor. So we don't have a cell on this loop. What is happening here is we have current across R5, which is that current I1 minus I2 minus 0,2. But what is happening across R4, R40, we have current. So unlike here, where we had arrows going in the same direction, here we have current going this direction, current going that direction. So we have two currents that are going in different direction. So this one is the positive direction, this one is the negative direction. So with this in mind, let's now set an equation there. We don't have a cell, so 0 is equal to, sorry about moving the camera, 0 is equal to the current in the positive direction, which is the voltage in the positive direction across this R5 is the product of current and resistance. So we will say I1 minus I2 minus 0,2. Now across this resistor we have current in the different direction. So we will have minus R40 in this case multiplied by I2. I think this helped you to understand how we came with that formula. So now let us substitute. R5 is 5. We don't know I1 yet. We don't know I2 yet. 0,2 comes back as it is. R40 is 40 and I2. So we know that we will have 5I1 minus 5I2. We said 5 times 0,2 is 1 minus 1 minus 40I2. So we add 1 here also. So 1 is equal to, that one cancels this one. So we have I1, 5I1. We have I2. Sign is negative. So we're gonna add this. So it's gonna be minus 45 I2. So this is our second equation. So which one is easy? Must you make I1 subject of the formula here or here? If you ask me, I would rather come here and say, I'm going to transpose, I'm going to take this to this side, and the sign is going to change. So it's going to be 1 minus 8 I2 equal to I1. So I1 is the same as 1 minus 8 I2. So you call this equation 3. Then you take this equation 3 and you substitute it there where there is I1. So 1 is equal to 5 into 1 minus 8 I2 minus 45 I2. So we have 1 equal to 5. 5 times 1 is 5. 5 times 8 is 40. Minus 40 I2 minus 45 I2. So now we've got I2 and we've got negative and negative. So that means we are adding. So we'll end up with 85. So let us subtract minus 5. Subtract minus 5. Put back the positive sign. So this one cancels this one, and this one add and make minus 85 I2, and here we'll have minus 4. So we divide by minus 85 because we want I2. Minus 85. So we would have I2 that is positive, and 4 divided by 85, 4 divided by 85 is equal to 0, 0,047a. So we know I2 is 0,0047a. Now we can substitute this I2 here to get I1. So I1 is equal to 1 minus 8 into 0,047. And if we say 0,047 times 8, what do we get? We get 1 minus 0,376. If we then say 1 minus 0,376, what do we get? We get 0,624a. Then this is our I1, this is our I2. So if they would give you this, you would kill it. You would have your marks taken easily.